revision. So let us have a look at some of the questions that we encounter, right? So this is coming from the November 2022 IEB math paper. And have a look at this question, see what it says. And it is 6 marks, this question here. Now remember, you need to use all your knowledge of trigonometry to solve this. So this is IEB November 22. Right, so I'm sure you can see this question on your screen. See what this question says. If 2 cos 2a plus sine 2a is equal to r cos 2 alpha minus beta, where r is positive and beta is an acute angle, determine r and beta. Okay. Now, thinking about the question, what would you do first? Anyone knows what to do first? Just by looking at the question. Okay, look on this side. We can't do much here, right? Because this is, of course, you can go and expand it and stuff on this side. I would go and expand R here, right? So I'll take this equation. Okay, I will take this equation and I will expand that part first. So I will start by using this equation to solve for R and beta. So prove, because this is the condition that is given. So this is my solution. Now we got 2 cos 2 alpha plus sine 2 alpha is equal to R. What is cos of 2 alpha? It's your double angle expansion, which is cos 2 alpha cos beta plus cos minus sine, right? So because this is a minus, that's a plus, cos plus sine 2 alpha sine beta, right? Now obviously you need to take the R inside. If you multiply the R together with this, you can get R cos 2 alpha cos beta plus R sine 2 alpha sine beta. Okay, so far is good. Now what we're going to do is we're going to equate the coefficients of this part with this part, equate this to this, and equate sine 2 alpha with the sine 2 alpha part. So we're going to equate coefficients. So we say 2 cos 2 alpha is equal to R cos 2 alpha cos beta. Guess what? If you divide both sides over here by 1 second, we have 2 equations here. So let me just simplify this. So if you divide this side of the equation, both sides by cos 2 alpha, right? You will get 2 is equal to R cos beta, okay? 2 is equal to R cos beta. So this is equation 1. And we're going to equate this one to the next one, right? So you're going to say sine 2 alpha is equal to R sine 2 alpha sine beta. R sine 2 alpha sine beta. So if we cancel out sine 2 alpha on both sides, over here we're going to get 1 is equal to r sine beta. Okay? So over here, this part is telling me that cos beta is equal to r over 2. This part is telling me that cos beta is equal to r over 2. If I divide both sides by, sorry, 2 over, cos beta is equal to 2 over r, not r over 2. Cos beta is equal to 2 over r. 2 over r, because I'm dividing both sides by r, right? And this one is telling me that sine of beta is equal to 1 over r. We should work with one of the equation. Let's draw a triangle for this, okay? Yeah. If you draw a triangle and put beta here, right? We are getting 2 over r. Cos beta is 2 over r. This is 2, thus r, right? And this is square root of r squared minus 4, right? Because the opposite is the hypotenuse squared minus the adjacent squared, right? Remember, cos beta is 2 over r. Now, if I ask you what is, from this triangle, what is sine beta? You're going to say sine beta is opposite of a hypotenuse, which is square root of r squared minus 4 over r. Now you have sine beta here, and this second part of the equation is also sine beta. So now we can equate both. We can say this is equal to, remember this is also sine beta, and sine beta is 1 over r. Okay, now what we can do is we can get rid of the r's and solve them. And we say r square root of r squared minus 4, squaring both sides, we can get r squared is equal to 1 plus 4. Right, why? Because I cancelled out the r's, I squared the side and I took the minus 4 over. So r is equal to square root of 5 if r is positive. Did they tell us r is positive? Did they tell us that r is positive? R is positive and beta is an acute angle. Determine r and beta. So we calculated r, right? Now, obviously, if you calculate r, beta is easy to calculate because if r is square root of 5, then you got 2 over root 5. So to calculate beta is easy. Cos beta is equal to 2 over root 5. So beta angle is now equal to cos inverse 2 over root 5. And see what we get, 26.57 degrees. Right. That's why this question was nice, right? So we got r, which is root 5, and beta is 26.57 degrees. So nice question here, right? Something different. Is this difficult? Hence or otherwise determine. Oh, hence or otherwise determine. Look at this followed up question, the 2-mark question. Hence or otherwise determine the maximum value of 4 cos squared alpha plus sine 2 alpha. Now we need to look at the top part, right? Now we need to look at this part and see how to simplify it into this. So we know 2 cos 2 alpha plus sine 2 alpha is equal to root 5 cos 2 alpha minus 2 alpha minus what? 2 alpha minus minus beta. Remember the beta angle is already given and I substituted root 5 in there, okay? The beta angle is already given, so I've substituted root 5 inside here, and the beta angle is 26.57 degrees. Now, 2 cos 2 alpha plus sine 2 alpha. But see what they have here in this expression. This expression says that, all right, so we are given this, and this expression is saying something else. That expression is saying 4 cos squared alpha. This part over here. Now, question is, how did they get the 4? Right, but remember, this is alpha here. This is alpha and that is alpha. So we need to look at the equivalence of this. So we need to rewrite it as in terms of cos 2 alpha. Remember, this is 4 cos squared alpha. What is cos squared alpha? Cos squared alpha. Remember the cos double angle. When you solve for cos squared alpha, the cos double angle says this. Cos double angle in terms of cos says 2 cos squared alpha minus 1. All right, so I want to know what is cos squared alpha. Cos squared alpha in terms of double angle, because this side I have a double angle, all right? Unless we change this side into a double angle. Because they want the maximum value of this part. Okay? Unless we change this side into a double angle. Either way, it's going to work both ways. All right, so now I want to check what is cos squared alpha. I'm solving for this. So I'm going to add the 1 and then divide it by 2. So 4, this is basically equivalent to 4 cos 2 alpha add 1 and then divided by 2, right? Plus sine 2 alpha. So I converted it into something like this. Now 4 times 2, 4 times half is 2. Yes, remember 4 divided by 2 is 2. 2 times cos 2 alpha is what? 2 cos 2 alpha. 4 times, not 4 times, 4 divided by 2, I did that already. I took 4 divided by 2, which is 2, and then multiplying this inside, and then multiplying there. So plus 2, right? Plus sine 2 alpha. Look, guys, we already have this expression. See, 2 cos 2 alpha, sine 2 alpha, right? So we got 2 alpha, cos 2 alpha, 2 cos 2 alpha, plus sine 2 alpha, plus 2. Okay, now we already know what this part is. This part is root 5 cos 2 alpha minus beta. Right? And then plus 2. Now, basically, we converted this into this. Now we want to know what is the maximum value of this function. Well, the maximum value of this trigonometric function is the number in the front, which is root 5. Max value is equal to square root of 5, and then it's shifted up by 2 units, so plus 2. All right, guys, that's the maximum value. And the minimum value will be minus root 5 plus 2. Very nice question. Okay. So there was one more question in the IB paper, right? That I want, yeah, this question here on 3D. Question 10 on 3D. Right, so I hope you guys understood all this, right? Very nice question. Now, remember, this 3D problem, you need to look at it in practically. So it's basically a book, right? Or you can think of something else. Let's see, ABCD represent a closed door. So it's basically a door. So a rectangular frame, 1.2 meters wide and 2.2 meters in length. When the door is open 42 degrees along its hinge, there's a bottom piece here, right? 42 degrees there. Its new position is represented by AEFD. Determine the size of FAC. We want to find the size of the top angle. FAC. FAC. Okay? And by the way, it's not this angle here, right? They're making their own imaginary triangle inside. So what we can say at the moment that AF is equal to AC. We want to find this angle here, right? So what we can say is that AF is equal to AC, diagonals of rectangle. Okay, so let's write that. AF is equal to FC because that's diagonals of rectangle. Okay, AF is equal to FC because that's diagonals of rectangle. Then look at this bottom piece here. What is DC? We also know that DC is equal to AB. They are all, remember, DC is equal to AB is equal to DC. Because of opposite sides of rectangle. And we know that DC is equal to DF. DC and DF are also equivalent, okay? DC and DF are equivalent because they are sides of rectangle. See, there's another, it's a door frame, all right? This is opposite sides of rectangle as well. This won't be opposite side, this will just be sides of rectangle. Sides of rectangle. Okay, now, after we have all this, remember the first thing to do over here will be to calculate FC. If you can calculate this length FC, right? And then calculate AF and AC, we are sorted, right? So now let's start by calculating FC. So you need to look at this triangle here. In this triangle, we have side angle size. So this is 1, 2. And that's also 1, 2 meters. See, it's a door frame. So the top and the bottom are the same. This is also another door frame, identical. So top and bottom. Now, so let's see. We want to calculate DC. No, sorry, we want to calculate FC. So we say FC squared is equal to 1, 2 squared plus 1, 2 squared minus 2 into 1, 2 times 1, 2 cos of 42 degrees. Right, I'm just going to put the whole thing on the calculator and square root it. So I'm just going to put a square root and finish the whole thing on the calculator. So that's 1.2 squared plus 1.2 squared minus 2 times 1.2 squared, right? Because that's 1.2 times 1.2. And then we have cos 42. And the square root of that is going to give us 0,86 meters. This is in meters, right? 0,86 meters, yeah. Right. Now, that is 0,86 meters. The next thing is that we know that AC is equal to AF. And now how do we calculate AF or AC? To calculate AC or AF, that's diagonals of rectangle, and you know that is 90. So look at this, right? Look at in triangle ABC. In triangle ABC, we have angle B to be 90, right? That is what? That is angles of rectangle. Now we can solve Pythagoras here. We can say AC is equal to, remember AC was equal to AF, which is the same thing as saying using Pythagoras. We're going to say square root of 2.2 squared. Remember this is 2,2 and this is 1,2. So 2,2 squared plus 1,2 squared. That's Pythagoras. So square root 2.2 squared plus 1.2 squared. And we get 2.505, 2.51, 2.506, 2.506. Yeah, I think we can just use 2.51. Right, we got 2,51 meters, which is the diagonal. Obviously, the diagonal will be the longer. Now, in triangle ACF, we got FC. Now we can calculate angle A. And remember what I told you about angle A. So you have a diagram like this now. Right, you have a diagram like this where these two are equal, right? And this is A, and this is F, and that is C. Those two are equal, you are even given FC, right? Uh, FC is 0,86. And we just solved here, which is 1,51 and 1,51. Right, so now we're going to use this 2,51, sorry, 2,51. And this is also 2,51. Now we are going to simplify this, all right? Because remember, we want to find angle A. Right, so to find angle A, in other words, FAC, we're going to say cos of angle A equals minus A squared. So what's the other two sides squared you left with? F squared plus C squared divided by 2FC. Now, what is cos of A? Cos of angle A, that's what we want to find. What is A squared? A squared is 0,8 squared, right? It's opposite angle A, 0,86. And what's the other two? What is F squared and C squared? Isn't they equivalent? Yeah, they are equivalent because that's 2,51, 2,51. So since those are equivalent, just can write 2,51 squared plus 2,51 squared and divided by 2 times 2,51. Right, and we will get a decimal value for this, or you can just say angle A is equal, or angle FAC is now equal to cos inverse of this answer here. So we can work that out. 2.51 squared times 2 minus 0.86 squared divided by 2 times 2.51 squared. Yeah, that is 0.94. 0.94, I'm going to say shift cos the answer, right? And I'm getting 19.73. 19.73 degrees. Okay, so nice problem. Sometimes they also give you a problem that the book is opened and they draw an imaginary triangle and you want to find the angle between, right? The diagonals. Right, so that's a nice question as well. I'm sure you must have came across something like this. Now, we want to go to the rest of the papers and solve. Okay, so if I go to let me solve this paper first, since we in KZN, right? Right. I want to solve some trigonometry questions from the different provinces. Obviously, these are important because there are some difficult questions here. Let's see. So this is coming from KZN, March 2025. So where is this coming from? KZN, March 2025. Right, so last year's KZN paper. Now, let's have a look at this question. If 5 sine beta minus 4 is equal to 0 and beta is between 90 and 270, right, so obviously first quadrant is eliminated. You have to put sine in either the second, the third, or the fourth quadrant. Determine without the use of a calculator and with the aid of the diagram the values of what is cos beta. Obviously, you need to draw a diagram. So the first part, we draw a diagram because sine is what? Sine is positive. Why? How we know sine is positive here? Sine beta is equal to 4 over 5. You need to solve this equation. Always solve that equation, all right? So we have 5 sine beta is equal to 4. Take it over. And then sine beta is equal to 4 over 5. And this is positive, and 90 to 270, that's also positive. So it will be in the second quadrant, okay? Where is sine positive? Right, so there's your angle beta. There's a reference angle inside the triangle. And sine is opposite over hypotenuse, so 4 over 5. And the adjacent is x. X is equal to -3 from Pythagoras, okay? So value of x is -3, okay? That's the one you need to solve. Now, or you can say x squared is equal to 5 squared minus 4 squared. That's coming from Pythagoras, right? So x squared is equal to 9. X is equal to plus minus 3. Since x is less than 0, we only take one answer. X is equal to -3. That's how you show that. You only take the negative part. I think this is just extra. It's implied that you know how to solve this and complete the triangle. Now, to find cos beta from here is cos of beta is -3 over 5. Okay? What is cos 2 beta? Cos 2 beta, they are just applying what are we applying now? The double angle. In terms of, you can use the double angle in terms of sine or in terms of cos. So you can say double angle. I like to use this one, the first one, cos squared beta minus sine squared beta. Okay. Now, what is cos squared beta? Cos is -3 over 5. And what is sine beta? 4 over 5. Right, so I've got 9 over 25 minus 16 over 25. And 9 minus 16 is -7 over 25. Okay? And now how are we going to find sine 3 beta? This is 4 marks. Sine of 3 beta. Okay. Now this is, see, something different. And this is where most students will get stuck. Because now sine 3 beta, what must you do? Well, is go and start using your expansion angles, right? So say sine 3 beta is equal to sine 2 beta plus beta. Break it down like this. Now, what is the expansion for sine? You say sine 2 beta cos beta plus cos 2 beta sine beta. But now what is sine 2 beta? We didn't calculate sine 2 beta, right? Because sine 2 beta is 2 sine beta cos beta, right? Times cos beta plus, but we already have cos 2 beta, right? So there's no need to expand that. So that is cos 2 beta sine beta. No need to expand cos 2 beta because we just found it. Now we just substitute everything inside. This is 2. What is sine of beta? 4 over 5. What is cos of beta? Minus 3 over 5. What is cos of beta? Minus 3 over 5. Plus, what's cos 2 beta? Minus 7 over 25. And what is sine of beta? 4 over 5. Okay, because cos 2 beta, we just solved in above. Okay? And now we'll solve all this. So that's 8 times 9, which is 72. And that's 5 cubed, which is 125. Minus 7 times 4, which is 28, divided by 125. You should get that answer, 72 minus 28. Okay, 44 over 125. Okay, guys, easy. All right, so that's your answer. That's it, without using a calculator. I just needed to minus 72 and 28. Okay. Even the last two questions, look at this. Look at this, 6 marks, 5 marks. It's a disaster of a paper. Right? We'll go through it quickly. Right? Now, we will simplify everything. Now, remember, we're going to add, best thing to do is add 360 when you see a negative angle. All right, so this will become sine 180 minus theta. Tan 180 minus theta, we can simplify that. That's in the second quadrant, so negative tan theta. Cos of negative angle is like adding 360 in here. So that's in the fourth quadrant, which is just cos theta divided by cos squared 90 plus theta. Remember, cos of 90 plus theta is negative sine theta. Okay, now because you're squaring it, then it will become positive. So it's basically negative sine theta squared plus 3 sine squared theta, right? You're almost there now. Now the next part is simplifying this. So sine of 180 minus theta, that's in the second quadrant. So sine is positive. Tan is sine over cos. And that's cos theta. You can see cos and cos cancelling out. And the whole thing is over over sine squared plus 3 sine squared, which is 4 sine squared, right? So sine squared theta plus 3 sine squared theta, right? So that is 4 sine squared theta. And on the top, I've got negative sine squared theta, right? Because cos cancel out, that's negative sine squared theta. Nice. All right, so you can see sine squared cancelling out. And the answer is just negative quarter. Okay, guys. Right, so it wasn't so bad. Right, just reduction angle and simplifying. This is more like basic grade 11 knowledge. The last question. Prove the identity. So when you say left-hand side is equal to 1 over 8 into 1 minus cos 4x, right? Now I want you to think about what is cos 4x, right? I want you to think about what is cos 4x. So cos 4x is the same thing as saying cos 2 times 2x, okay? Now I need to put this in terms of, I think we should just put it in terms of cos only, right? So it's like cos 2 theta. That's basically 2 cos squared theta minus 1, right? Uh-huh. How are we going to come to that part? Cos squared minus sine squared. What if I put it as cos squared minus sine squared? It's going to be, remember, if you're calling this the theta angle, in other words, that is going to be 2 cos squared 2x minus 1. So we can replace this inside here. What is cos 4x? 2 cos squared 2x minus 1. Ooh, this is like a looped sum. Okay, so I've got this part that I've used inside here, right? Now I want to know what is cos 2x. You still got to replace this part also, guys. See here. Still got to replace this. Wait. So far what I can see is 1 minus 1. That's going to become 2. 1 over 8. See, you got 1. See, if I try to simplify this, I've got 1 minus 2 cos squared 2x. Minus and minus becomes up plus 1. Right? So you got 2 minus 2 cos squared 2x. 1 plus 1 is 2. Yeah. Remember, we can take out 2 as a common factor. So we're left with 1 minus cos squared 2x. 1 over 8 times 2 is quarter. 1 minus cos squared 2x. Now the problem is, what is cos squared 2x? What is cos 2x? Cos 2x is basically 2 cos squared x minus 1. So now you must take this and replace it in cos 2x. We want to know what is cos 2x, this part here. Cos 2x is 2 cos squared x minus 1. That's 1 minus, yeah, like that. 2 cos squared x minus 1. But now how will that end up being sine squared? How will that end up being sine squared x times cos squared x? I'm going to end up getting cos 4 here. 1 second. Let me just see if I substituted everything correctly. Cos 4x is 2 cos squared 2x minus 1. 2 cos squared 2x minus 1 So I ended up with that 2 cos squared 2x minus 1. That's fine. We got 2 as a common factor. We got quarter into 1 minus cos squared 2x. Okay, I'm just going to simplify and see what I'm going to get here. That's quarter 1 minus squaring this. I'm going to get 4 cos 4x. Multiplying these two binomials out, I'm going to say plus, not plus, minus 4 cos squared x. Why? Because the product of these two are the opposite sign, and then times 2 because it's squaring a binomial, and then plus 1. So I've got quarter to 1 minus 4 cos 4x plus 4 cos squared x, right? Minus 1. So now what I can see is that 1 and the minus 1 cancels out. Then I can take out 4 as a common factor. If I take out 4 as a common factor, so I've got quarter into 4 into cos squared x minus, I'm just rewriting it in polynomial, I'm just rewriting it in the order here. Just putting the positive parts first. Okay. If you're going to write it out like this, then put a negative and then a positive. Cos squared x. Okay. So I've got negative cos for, okay, so I managed to eliminate all these numbers, right? Now I'm left with cos squared x and negative cos 4x, cos x to the power 4. We want sine squared times cos squared, sure. Right, so what we have here is cos squared x minus cos 4x. Cos squared x is, wow, how did I end up with this? Cos squared x minus cos 4x. Cos squared x minus, I ended up with a minus. I should have tried the right-hand side into a left-hand side. Oh, wait a second. Isn't we got this simplified form? And then obviously you can also do this now. That was the left-hand side. So if you get stuck over there, do the right-hand side as well then. We can do the right-hand side and see this is RHS, okay? We can just make left-hand side equals to right-hand side if you get stuck like this. Right, we want to keep the cos squared, so change the sine squared. Change the sine squared into 1 minus cos squared x. Right, cos squared x change the sine squared into 1 minus cos squared x. Yes, so that's cos squared x minus cos 4x. Right, so now therefore, left-hand side is equal to right-hand side. So I couldn't get the left-hand side being equivalent to the right-hand side, so I simplified the right-hand side as well. So now they are equivalent. All right, so nice question, guys. You can also do it like this. Once I was working through the problem, I said, why didn't we take this into that? That would have been much more easier. It's just the algebra was quite long. Or, come on, you got to know how to solve these things. Or, let's take the right-hand side. Okay, is equal to. See what we have here. We got sine squared x and cos squared x. So we got sine x. See how I'm going to break this up. Sine x times sine x. Cos x times cos x. Now what I'm going to do is I'm going to take a sine x and a cos x, and I'm going to take a sine x and a cos x. I'm going to group that up, all right? And now what I'm going to do is multiply it by 2. So obviously you're going to multiply by 2. You must multiply by half, 2 times half. So you change nothing here, right? And do the same here, 2 times a half. So what did you do here? You change nothing, right? 2 times half is just 1. So nothing changed. The expression did not change. But what you know is that 2 sine x cos x, that will become half sine 2x. And this one over here will become half sine 2x. That will become quarter sine squared 2x. Okay? Quarter sine squared 2x. That is correct. Ah, and then what is sine squared 2x? What is sine 2x? No. Then we're going to go back to that. Sine squared 2x. We want sine squared 2x. Okay. Quarter sine squared 2x. Guys. This is going to be a little bit more difficult. Right hand side. Because you have to end up using like sine 2x. How can I get sine? Can I use the double angle? Can I use this compound angles identities to get? Remember, you have to use all your knowledge. So I'm trying to get I'm trying to get sine 2x here, right? Watch what I'm going to do. This is the same thing as saying quarter into sine 2x all squared. How can I get sine 2x? To get sine 2x, let me expand. I need to put sine 2x in terms of cos. That's where the problem is. Putting sine 2x in terms of cos. Sine 2x. I can't put, because sine 2x is 2 sine x cos x. It's like going back there. I don't want to do that. I'll put sine 2x in terms of cos. So let me use a double angle expansion for this because I don't have a rule to put sine 2x in terms of cos 2x. Sine x sine x minus y. 1 second, because sine 2x supposed to be equals to 2 sine x cos x. Getting stuck here as well. I think that would just suffice here. Unless we can change this side into quarter sine 2x all squared. Try this. This is quarter. What is sine squared 2x? That's 1 minus cos squared 2x. Basically an identity I used here. Will this help? Yes. This will help. All right, so I used an identity here, the square identity. Sine squared plus cos squared is equal to 1. Now we know cos 2x. Now we can substitute the previous one. Cos 2x is equal to 2 cos squared x minus 1. Yes, so now what you are solving for is that is cos 2x. So what is cos 4x? Watch here. It's 2 times double, 2 times the angle. So what if I say cos 4x? You can see the relationship between this double angle and this is half, right? So if I say cos 4x, this will be 2 cos squared 2x minus 1. Now you are solving for this cos squared 2x. That will be cos 4x, bring the 1 over, and then divided by 2. That is cos squared 2x. Now we can substitute this inside here, and then we'll get the answer. Sure. Minus cos 4x plus 1 divided by 2. Right, so now you can see the LCD is 2 here. Yeah, the LCD is 2 over here. Okay, no, don't worry about the LCD. Let's factorize, let's open up the bracket. So that's 1 minus cos 4x over 2 minus a half. Okay, now you got quarter. Just doing algebra here now, guys. 1 minus half is half minus cos 4x over 2. You can take out half as a common factor and we're done. Right, so that's 1 over 8 into 1 minus cos 4x, which is the left-hand side. Sure. All right, guys. So that's why this was a little bit challenging, right? So be careful. Obviously, this one was much longer, but you see, this is still a way of a proof. See, I got stuck over there, so reduce the right-hand side as well. So left-hand side is equal to right-hand side. And then this one over here, I had to think about a little bit, but it's fine. We just needed to substitute the identity here, and we are done. All right, so nice question there as well. Let me just see if there's anything exciting in the graph. So we got a sine and cos mixture, right? Okay, okay. His questions towards the end is a little bit difficult. Okay, we're just going to do it quickly. Determine the general solution of, when you're finding a general solution, which one is it easier to change? Okay, it doesn't matter. So we know that we have to use 90 minus 90 plus, or we use the cos diagram. So we have a cos here. We need to change the sign into a cos. So we got cos of 90 minus, all right? Or, so now we know that we can drop off the cos on both sides and then solve. And by adding 360, K360, or you can say cos of x minus 45 is equal to cos. When will you get cos positive? Remember, this part is positive, huh? Cos of something is positive. When will you get cos to be positive? In the fourth quadrant. So we're going to use 270. Okay? Because what is cos of 270 plus 2x? That's in the fourth quadrant, and cos is positive. Okay? So we're going to drop the cos here, and then it's easy to solve because we're finding general solution. That's x minus 45 is equal to 90 minus 2x plus k360. Right, so take this 2x over, we get 3x is equal to 90 plus 45 is 135 plus k360. So x is equal to 45 degrees plus k 120. K is an element of z. Next one, x minus 45 is equal to 270 plus 2x plus k360. X is equal to, no, negative x, because that minus that. 270 plus 45, that should give me 315. 270, yeah, plus K 360. So X is now equal to negative 315, negative K 360. You can leave your answer like that. Okay. So two general solutions. Look, you could have kept the sign and then change it. So remember, oh, I'm gonna show you the other trick as well. See, that was changing the, what about this? Oh, if you don't want to use 270, then you always need to uh, uh, change the cos, keep the sign, okay? So when you say sine 2x is now equal to sine of 90 minus the angle, which is x minus 45, okay? Or sine 2x is equal to sine of 90 plus x minus 45. And you can proceed in this manner here by dropping off the signs, right? And adding, because remember sine of 90 plus the angle is cos of the angle. So you change the cos, okay? So you got 90 minus, so that's 135 minus x plus K 360. The minus x comes over, it becomes 3x equals 135 plus K 360 divided by 3. You get the same answer, right? Or you got 2x is equal to 90 plus x minus 45 plus K 360. X is equal to 45 plus K 360. Only this one looks different because this is a negative angle, right? And using coterminal angles, I can prove that negative 315 is the same thing as saying 45. And the negative and the positive in front of the K doesn't matter because K is an element of integers, right? Especially when you're multiplying by 360, right? So you can say K 360. So I can convert this into a positive. No need to convert here, it's fine. So you can see the answers are equivalent. So what will you do when you have sine and cos mixture in future? Just change the cos, so you don't have to use 270, right? Keep sine fixed, right? Change the cos. So you're only working on 90 minus 90 plus. Okay. Only problem is, what if you have sine 2x is equal to negative cos x minus 45? Then when you sign negative, you see, that's a problem. So try to solve the problems in either way, right? Using the cast diagram, right? The reason why I used 270 plus here, because cos is positive. Remember, this entire result here is positive. How we know the entire result is positive? Because there's a, sorry, not, it depends on the angle, of course. We know the sign in the front of this is positive in terms of graphs, right? So nice question. Yeah, the questions towards the end were like crazy. So I just want to cover that up quickly. I'm sure we can solve these fast, right? In these graphs. Right, so they already told us the general solution there. We know what the general solutions are. So we got f of x, which is sine 2x, cos x minus 45. So it's coming from the top, are drawn in the interval a minimum point, maximum point. The two graphs intersect at B and D. B, C, and D, 3 points of intersection. Write down the period of G. Period of G, the G graph, count one period. Period of G will be, what is a G graph? G graph is, the period is normal. You can see there is no coefficient of X there. So the period is just 360, okay? Write down the coordinates of A and B. What is the coordinate of A? The minimum value, all right? A will be on the graph of G, all right? It's a shifted graph, okay? The graph of G is a shifted graph. And how is it shifted? Remember, the graph's supposed to start here, but you can see it got shifted 45 degrees to the right. Now, if you imagine the original cos graph, it starts like this, right? Goes down, right? So if you're imagining the original cos graph, where is the next point? This point is 180, right? It's at negative 180. Now, if you're going to move this point, if you are going to move this point 45 degrees to the right, it's going to go at negative 135, okay? So that's why this point over here is negative 135. Negative 135 and 1. So what's the coordinates of A? Negative 135 and 1. Negative 135 and negative 1. What's the coordinates of B? The coordinates of B is a point of intersection, so you need to look in your general solutions, okay? In your general solution, you had 45 degrees plus K360. Wait a minute. Why did we get the same answers in both cases here? 45 plus K360. Oh, it's not K360, K120. Be careful. Go back. This is K120. 360 divided by X, K120. So we end up with the identical answer here. All right. Anyways, we want to find the value coordinates of B. So obviously, you're not going to substitute here. You will substitute over here. So if the value of K is 0, we will get negative 45, but negative 45 is here. No, sorry. If the value of K is 0, you're not going to get negative 45. You will get 45 degrees. If the value of K is negative 1 might work. What's 120 minus, what's negative 120 plus 45? We have negative 120. Make sure you're understanding. We good? That's negative 75. Right, so I've got negative 75. Right, so I've got negative 75 degrees. So coordinates of B is negative 75 degrees. Now, where will you substitute negative 75? So this is part 2B. I will substitute into either equation, whichever one is easier. Sine 2x. Let me just substitute into sine 2x. F of, this is the F graph, sine graph, right? So F of 75, negative 75 is sine 2 times negative 75, right? Sine 2 times negative 75 is sine of negative 150. That's easy to simplify. That's negative 150 is in the second quadrant, negative half. So it'll be, the y value is actually negative half. But the same, I just write it down, okay? So you can just write down the answers for 2 marks each. Great. And I just showed the calculation in the side. You can just type this into the calculator, right? Next part. Look at the last 2 questions. The last question was 5 marks. Use a graph to determine the values of x in the interval. Okay, put this down. You to explain that. So this is what I have. Use the graph to determine the values of x in the interval 0 to 180. So we are only looking on this side, right? 0 to 180. In the interval 0 to 180, where f of x over g of x is less than 0. So one above, one below. So one graph must be above, one must be below. All right, so above and below, not both above. So remember, positive over negative. When will you get less than 0? Positive over negative is less than 0, or negative over positive is also less than 0. So those are the two cases, okay? Okay, those are the two cases. So let's see over here. 0 to 180, all right? One must be above, one must be below. So there's, look here. Look between these points. That point there and that point over here, right? So this piece over here is below, right? And this piece over here is above. That's what we want, above and below, okay? So we want to know what is this point of intersection. I think this point should be 90 to 135, yeah. So between 90 and 135. So you can say x is an element of 90 degrees to 135 degrees. Make sure you don't include 90 and 135. You don't want zeros. Okay. So it's between 90 and 135. Okay. Or you can write your answer like this. It's x, not theta. We wanted the intervals when one is above, one is below. Next one. Solve for x in the interval. Solve for x in the interval. Now watch how they have given us this question. Very fancy. And it's 5 marks, all right? So I'm going to do it in the side over here. Why did they give us 1 over root 2 cos x sin x? Ah, there's a reason why they give you that. We know sine 2x. What is sine 2x? Sine 2x is f of x. Now, how are you going to make this g of x? That's what they want to see, if you understand this. Right, so another question, this is f of x. We know that is f of x is greater than. You take this 1 over root 2 inside the brackets, because we need to try to make this g of x. How? Cos x times 1 over root 2. You'll understand why I'm writing it out like this. Cos x times 1 over root 2 plus sine x times 1 over root 2. I'm going to change the 1 over root 2 into cos 45 because it's a special angle. Cos x cos 45 plus sine x sine 45. And that's what you can also do in trigonometric equations. So this is cos, cos, sine, sine. So that is just cos of x minus 45. So f of x is greater than g of x because that was g of x, cos of x minus 45. Now what do you want in this case? When is the f graph above the g graph? Right, so the f graph is above the g graph right here. Look at these lines here. Right, so what's happening here? This graph, let me use another color, red, right? So this is the graph of g. This is f. This is g, and this is f. Oh, it's equal to as well. Be careful. So we want equivalence. So we can see f of x is equal to g of x at point C. So we need to write this as a single answer. X is equal to 45 degrees. Or we want f above g. So g graph, all that is g. So f graph the only place where f is above g, this whole thing is g. F graph is below g. F is below g. Come here. Ah, this is a place F and G. So from point D. Now, what is point D? Again, point D is, what was the difference? You can use symmetry to solve for point D. What was the difference between 90 and minus 75? It was 15, all right? So I can probably just minus 15 degrees here, and I can get 165, right? So it's from 165. I'll show you how to get this point again, all right? So you can say X is between 165 and 180. Yeah. So that's your answer. For one, now I wanted to show you how to get 165 here. I just use symmetry to solve for 165, right? So what you're going to do is, you know, the general solution that you had, put k value as 1. So 120 plus 45 is 165. So that works out as well. Okay. So very nice questions. A little bit challenging. This, especially this part here. Right? So challenging question. Not straightforward. And what else was a challenging question here? This question here, big challenge. A crazy question. Right? And then what else was a challenge here? This one here. This one with the sine 3 beta. Right? So I put all the asterisks for you. The questions that are challenging. Just see. Right, I don't want to keep on doing the same thing, right? So redundancy, right? So I'm trying to avoid that. Okay, we can do one question here. So I'm looking at the Eastern Cape paper next. Okay, we will finish after this, right? So I'm going to try and work fast. I like the question with the cause for. So this is Eastern Cape, March 25. The first one was KZM. Yeah, I did put it there. Now, let's have a look at this. Sine 56 degrees is equal to Q. Determine the value of the following in terms of Q without the use of calculator. So obviously you need to go and draw a diagram, not a diagram in the cast, not a cast diagram, just a basic triangle question. And make sure when you're doing the triangle, you complete the triangle. Do not leave any part of the triangle unknown, right? So we know sine 56 degrees is equal to Q. So 56 is at the bottom. And a 34 will be on top, right? You have to calculate the top angle always. A sine of 56 is Q over 1. So this is Q, that's 1. I didn't leave anything now. This is Pythagoras. This is 1 minus Q squared. So this is a diagram for, you have to start your answer off like this, 1. Now answer the question. What is sine of negative 56? It is negative sine 56. They're just checking on your double angle here. Sorry, on your negative angles. So that's negative Q. What is tan of 124? Tan of 124, 10 is in the second quadrant, okay? So that's tan of 180 minus 34. Is it 180 minus? No, 180 minus 56. So that's negative tan 56. Is that correct? Was 180 minus 56. Now you good? You're understanding? It's 124. That's negative tan 56 is opposite of adjacent, q over square root of 1 minus q squared. Okay, so that's my answer. Q over the square root of 1 minus q squared. What is cos of 4? Whoa. Remember I taught you that before? So be careful of this. Anyone knows what's cos of 4? You put your microphone on and see. Try adding and subtract. Obviously, you can't add the angles. If I subtract the angles, not getting anywhere because 56 minus 34, 56 minus 34 is 22. They didn't ask us for cos of 22 or sine of 22, then we could have used compound angles. Neither did they ask for a double angles because 34 times 2 is 68, isn't? So they didn't ask for even 68 degrees. They asked for cos of 4 directly. So obviously, if everything fails, you go to special angles. So what the special angle says? Use a special angle, which is 30 and 34. Use 34 and 30. So that's cos of 34 minus 30 degrees. And that was 4 marks. It's difficult here with that level. Now, that is cos 34, cos 30 plus sine 34, sine 30. Right, so what's cos of 34? Now you need to flip the triangle, and cos of 34 is adjacent of hypotenuse, which is q over 1. So just q. What's cos of 30? Half. No, root 3 over 2. Sine 30 is half, okay? Sine of 34 is square root 1 minus q squared. And sine 30 is half. Now you can take the same LCD and write it over the entire thing. The same LCD is just 2. So root 3q plus square root 1 minus q squared. Well, you can't simplify that. So that's your answer in terms of q. Right. Note where you would have used double angles is for something like this. Right. So additional question for double angle, if they ask you sine 68 or cos 68, because that's 34 times 2. So this is a double angle question. Okay. Question on double angles. Let me just put DA for double angle, right? If they ask you a question on double angles, that's what they will be. But now this was totally different. So this is a double angle, and compound angle question will be either sine taking the difference 22 or cos 22. Then you will use compound angles. So be careful of these types of questions. I'm not going to do it because you already know what to do. It's something similar, just expansion and substitution. Now look at the proof of the formula, and many students, they mess up here. And remember, this is an examinable proof, both in IEB and NSC, right? So use the above identity. So they gave us cos A minus B, and we want to prove sine of A minus B, okay? Cos A minus B is this formula, right? We already know that. What is sine of A minus B? So to get sine of A minus B, we say left-hand side is equal to sine of A minus B, which is equals to cos. Change the sign into cos. You have to use the cos now. Cos of 90 minus A minus B. Okay. So what's cos of 90 minus the angle? Sine of the angle. And now proceed from here. So we're going to group those two. So it's a cos of 90 minus A plus B. Right. So I'm going to group this as a first angle, second angle. Now I'm going to use the cos expansion. So that's cos first angle, cos second angle, plus sine first angle, which is 90 minus A, and sine second angle. So cos of 90 minus A is sine A cos B plus cos A sine B. Supposed to be minus, right? Because this is a plus, so that must be a minus, yes. If there's a plus, it's a minus here. Whoa, 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 you can't use that. We can't use that because it must be 90 minus, so you have to use it like this. Yeah, you can't use that. You can't use a plus, so you don't have an identity for a plus. So the plus b, you're going to change it to minus minus b, as it is, minus minus b. So now you can use, because you got cos and you got a minus there, right? So cos 90 minus a, cos negative b, plus, now I can use the identity, plus sine 90 minus a, sine of negative b. Now, see what we're getting here. Cos, that is just sine a, cos b, cos of negative angle, plus sine of 90 minus a is cos a, and sine of negative b is negative sine b, because that's in the fourth quadrant and it's a negative angle. Now, you're getting sine a cos b minus cos a sine b. Okay, guys, make sense? So we have proved it. Right, excellent. Next part. Simplifies to a single trigonometric ratio. And this problem is nice because it's got a double angle there. I hope it works out. Let's see. Right, so we have sine 2a. Should we simplify sine 2a? Yeah. That's going to give us 2 sine a cos a. What's cos of negative a? Just cos a plus. What is plus cos 180 plus 2a? What's 180 plus 2a? Negative cos 2a times sine a divided by, what's a minus 90? A minus 90, I'm going to add a 360 here. Okay. If I add 360 here, it will become sine of 270 plus a. Now that will become fourth quadrant, and sine changes to cos, negative cos, because sine in the fourth quadrant is negative. Oh, you must have learned it like this. Sine of a minus 90 using a negative angle, sine of a minus 90 is the same thing as saying sine of 90 minus a. But remember, you had a negative angle, so the negative came out, and that becomes negative cos a. I'm getting the same answer here. This is in the fourth quadrant, and sine is negative, and it changes to cos. Right, so it's the same thing as saying negative. You can do it both ways. So this is negative cos a. So the bottom is sorted. Let's do the top. This is 2 sine a cos squared a minus. Now, because I've got cos squared here, it makes sense to put the cos 2a in terms of cos. Remember, negative and positive, I've already changed to minus here. Now, cos 2a is 2 cos squared a minus 1 times sine a. Right, so it's advisable to write it like this. Why? Because I already have a cos squared here, so I can factor it out. 2 sine a cos squared a minus 2 sine a cos squared a again, because I'm taking this inside, right? And multiplying by this. Don't forget the minus as well. And then I have minus sine a times minus 1, so plus sine a. Right, so now we can clearly see this whole thing and that whole thing cancels out. And that part is divided by negative cos A. So now you're left with just basically sine A over negative cos A, which is just negative tan A. All right, so negative tan A is your answer. Yeah, so nice question here as well, just using double angle and simplifying. Right, so we want to prove the identity first and then uh, check when it is undefined, when the identity becomes invalid. Given the identity, prove it. Oh, what is the 2 marks doing here? Okay, there's a typo there. So left-hand side is equal to, we need to come to this answer, right? So left-hand side, what is cos 2x? I need to see what to expand in terms of, right? So you need to expand the cos 2x in terms of cos and sine, because you got cos here and you got sine there. So cos 2x is basically cos squared x minus sine squared x. And then leave the balance plus cos squared x plus 3 sine squared x. Bottom, factorize it. Factorize the bottom 2 into, why are we factorizing the bottom? Because 1 minus sine squared is an identity. Now simplify the top. Cos squared plus cos squared is 2 cos squared x. 3 sine squared x minus sine squared x is plus 2 sine squared x divided by, oh man, this is so easy, divided by 2. What's 1 minus sine squared? Cos squared x. Okay. Take out 2 as a common factor on top. You're left with cos squared x plus sine squared x divided by 2 cos squared x. You can see the 2's cancel out. Cos squared plus sine squared is 1. You're left with 1 over cos squared x. Okay. Easy. Now, when will this identity become undefined? Now, very important is when they ask you this question, when will this identity become undefined? It will become undefined when each denominator is equal to 0. You have to set every single denominator equal to 0. What does undefined means? Division by 0, right? So looking for invalid identities, or when will the identities become undefined? When this denominator is equal to 0 and this one is equal to 0. So either 2 minus 2 sine squared x, either 2 minus 2 sine squared x, when each denominator is equal to 0. So this here basically means so 2 minus 2 sine squared x is equal to 0, or cos squared x is also equal to 0, right? So what about 2 minus 2 sine squared x? How are we going to solve that? We're going to say this part is, take the 2 over and divide it by 2. So sine squared x is equal to 1. Or, yeah, how are we going to solve this part now? Cos squared x equals 0 is just cos x equals 0, right? Now look at the graph of the cos. When is cos 0? When is cos 0? cos is 0 at 90, 270, right? And so on. So, but we only wanted the answer cos of x is equal to 0 between 0 and 180. So cos is 0 at 90 degrees. So x is equal to 90 degrees, right? And let's see when the graph of sine squared x is equal to 1. So sine can be positive or negative 1. So sine x can be equal to negative 1, or sine x can also be equal to positive 1, right? Because you're square rooting both sides. Now, when is sine x positive or negative 1? 0 to 180. So it's positive 1 at 90 degrees, okay? So x is equal to 90 degrees here as well. And so both cases, you're getting the same answer, right? At 90 is positive 1, and at 270 it is negative 1, but we don't want 270 as the answer. So just x is equal to 90. That's it. Right, guys. They didn't ask for a general solution. If they ask for a general solution, then obviously you got to solve these two general solutions. You have to solve each of these identities to general solution. So x is just 90. Last question. I'm sure you've seen something like this before, right? Okay, so you want the value of all the tans from tan 1 right up till tan 89. Okay, and it's a product of all these values. Now, I just want to explain something to you. Look at the triangle, right? Obviously, you're not going to, there's a trick to the problem, of course. I want you to imagine a triangle, right? And if I give you any triangle, right? Let's just say take a 30-degree triangle, and that's opposite hypotenuse, right? And this is root 3. If this is 30, that is 60. If I ask you what is tan, if I ask you what is tan of 30, tan of 30 is, if I ask you what's tan of 30, that's going to be 1 over root 3, okay? And if I use 60 degrees, if I ask you what is tan of 60, tan of 60 is root 3 over 1, okay? What happens if I take the product of these two? Isn't I will get 1. So I can say tan 30 times tan 60, the product is 1. So similarly, we can take tan 1, and now you can see the sum of these angles must be 90, right? So tan 30, tan 60, right? 30 plus 60 is 90. You can see the sum is 90, but when you take the product of tan 30 times tan 60, we're always getting 1. Right, so now you do the same here. So you can simplify this into tan 1 times tan 89. Right, that's grouping. Then tan 2 times tan 88, grouping again. Dot, dot, dot. The last grouping that you will do is tan 44, right, times tan 46. And then after you do that grouping, you're just going to be left with tan 45, because you can't group tan 45, just one tan 45, okay? Now, each of them over here will just be 1, 1, 1, 1. That's 1, that's 1, that's 1. And even tan 45 is 1. So you're just going to have 1 times dot, 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 1 times tan 45 is 1. So your answer is just what? Whole lot of ones. That's how you will solve it, okay? Right, you can see the sum is 90 each time, 2 plus 88, 44 plus 46, right? So this is a challenge question because you got to use a trick there. All right, so now we have a 3D problem. All right, so in the diagram below, triangle ABC is an isosceles triangle with AB equals BC. AB is equal to BC. Okay, that's given. So if angle C is alpha, angle A is also alpha, right? Angles opposite equal sides. BD is equal to AD is equal to 4. We have another isosceles this side. Wow. Wait a minute. So if this angle is alpha, this angle is also alpha because of this isosceles here now. So this angle D over here on this side will become 2 alpha, right? Exterior angles of triangle. 2 alpha. Mhm. And then I think the problem is solved. Let's see. Now, give reasons, guys. Don't just, write down stuff. Give a reason. Right, so the first part is show that ADB is 180 minus 2 alpha. So we need to use the geometrical proofs here. 7.1.1. The first part, what did we say? We said angle A is equal to angle C is equal to alpha. Why? Angles opposite equal sides. Then we said angle B1, B2. And we said angle B1 is equal to, then we said angle angle B1, you can call it angle B1 or angle ABD. Angle B1 is equal to angle A, which is also equals to alpha. Angles opposite equal sides, right? So we got two isosceles triangles there. So angle D, which is ADB, is 180 minus 2 alpha, which is a sum of interior angles of triangle ABD, right? And the second part, hence calculate the value of cos 2 alpha. Cos 2 alpha. All right, so guys, they want cos 2 alpha. What you're going to do is look at this triangle here. 1. So I think we got to use the cosine rule here. Can we use a sine rule? Sine alpha over 4 equals. If we want cos 2 alpha, no, we have to get it from the cosine rule, I'm sure. Yeah, so let's look at this. We're going to use in triangle ABD. In triangle ABD, cos of angle D1, call it D1, D2, right? Cos of angle D1 is equal to minus D squared. We have A and B here, so A squared plus B squared divided by 2AB. Now, cos of D1 is cos 180 minus 2 alpha. What's A squared? A squared is the opposite squared. Opposite A is 4. B squared is opposite B, which is also 4. D squared is opposite D, which is 6. And then divided by 2AB divided by 2 times 4 times 4. Cos of 180 minus 2 alpha is in the second quadrant, so that's negative cos 2 alpha. 4 squared plus 4 squared, that is 16 plus 16 is 32 minus 36 divided by, this is 16 times 2, which is 32. That's negative 4 over 32 is negative cos 2 alpha. So cos 2 alpha is equal to 1 out of 8. Yeah. So what is cos 2 alpha? 1 out of 8. Nice. So they didn't tell you to actually solve for angle D1. You could have solved for angle D1, right? Let's solve for it. Was cos inverse 1 out of 8. I'm getting 82.82, right? That's 2 alpha. And then divided by 2. I'll get 41.41. I'll get 41.41 degrees. 41.41 degrees, but that is alpha. 41.41 is alpha. And then obviously angle D will be 180 minus 2 times the answer. That will give me 97.18. But this angle is not more than 90. Well, the diagrams are not drawn to scale, okay? 41, 40. Yeah, this diagram is definitely not drawn to scale. That's why it's messed up. I don't want to know why they give problems like this when the diagrams are not drawn to scale. Because clearly 2 alpha is 81. Okay, so yeah, that's great. Let me look for a more difficult question. Let's look at this paper here. Okay. So if you go to the Northern Cape paper, look at this question 3. 6.3. Now, because you have done sequence and series, you can get questions like these, all right? So this is Northern Cape, March 2025 paper, right? Should be writing March. Given that cos x, sin x, and root 3 sin x are the first 3 terms of a geometric pattern, determine the value of x between 0 and 90. Now, this question is not difficult, right? So let's look at this. The first part is to find the common ratio. The common ratio is sin x over cos x. Or you can also get root 3 sin x over, this is not going to help you, right? Term 2 divided by term 1, but this one will help you. Root 3 sin x over sin x. So that is just root 3. So common ratio is root 3. But now, remember this ratio gave us 10x, right? And this ratio gave us root 3. So you can equate both because remember, both the ratios must be the same. So this implies tan x is equal to root 3. And now solve for x. Tan x is equal to, isn't tan of 60 is root 3? Tan 60. Yeah, it's a special angle. Tan 60 is root 3. Yeah, so x is equal to 60 degrees. There's it. Determine the value of x between 0 and 90. There's x is equal to 60. Second part. Hence, calculate the sum of the first 10 terms. Hence, calculate the value of the first 10 terms. So S10, Sn formula, right? We just write down the formula. Cos of 60 is root 3 over 2. Sin 60, cos 60. Hence, calculate the sum of the first 10 terms. So Sn is equal to, wait a minute, I just want to check the pattern out, all right? Cos of 60 is half. Sin 60 is root 3 over 2. Sine 60 is root 3 over 2. So I'm going to get root 3 times root 3 over 2. That's 3 over 4. Yeah, so it looks like you're starting from half and multiplying by root 3. Okay. So we can see the ratio, the common ratio is root 3, and the value of A is half. So we're going to write down Sn is equal to A r to the power n minus 1 over r minus 1. Okay. Now we can substitute everything inside here because we're trying to find S10. So this implies S10 is equal to A, which is half, R, which is root 3 to the power 10 minus 1 divided by root 3 minus 1. Okay. Root 3 to the power 10 minus 1, that's just going to be root 3 to the power 5. That's just going to be 3 to the power 5 minus 1. Why? Because this is 3 to the power half to the power 10, which is just 3 to the power 5. Are you going to use a calculator here, right? Zero 0.5 into 3 to the power 5 minus 1. Or you can type the whole thing in the calculator. I'm getting an answer of 165,29. Why are you getting a big answer? Because the sequence is divergent, it's getting bigger and bigger and bigger. So obviously, if you find a very large, maybe sum to 100, you get a very large number. Okay. And I want to look at this question here. Finding the general solution to something like this. Is it difficult? No. I will show you how to proceed, okay? Not difficult at all. So you can clearly see that you have, and this is a grade 11 problem because not grade 12 at all. Why? Because you got like a quadratic. So you just need to convert the sine squared in terms of cos. So you're going to say 6, 1 minus cos squared x minus 7 cos x minus 5 is equal to 0. 6 minus 6 cos squared x minus 7 cos x minus 5 is equal to 0. Make a standard form and write it out. Minus 6 cos squared x minus 7 cos x minus 5 plus 6 is plus 1 is equal to 0. Rewrite it out. 6 cos squared x plus 7 cos x minus 1 is equal to 0. You can use a calculator, solve it quickly. So you can say cos x is equal to, or cos x is equal to, so you're going to put 6, 7, and minus 1. So you're getting, whoa, wait a minute. Why are we getting fancy answers with a quadratic formula? It means that you need to apply a quadratic formula here. That's crazy. 6 into 1 minus cos squared x minus 7 cos x minus 5 is equal to 0. I'm just double checking my method. 6 minus 6 cos squared x minus 7 cos x minus 5 minus 6 minus 7 plus 1. Everything seems fine. No issues here. So we need to, obviously you can't factorize this. So you use a quadratic formula. You're going to say cos x is equal to minus b minus 7 plus minus square root b squared, which is 7 squared minus 4ac. Show you how to cheat quickly, right? Times negative 1 divided by 2 times 6. Right, so you're going to say cos x is equal to, that's the answer you got here, 0, 0,13, or cos x is equal to negative 1,30, negative 1,30. But now remember, cos can't be negative. The value of x, the maximum value of cos x is 1 and the minimum value is -1. So remember the cos graph only goes between, so it can never be negative 130. So not applicable here. You can't solve for this. But this one you can solve. So x is equal to, you can say reference angle. What's the reference angle? Shift cos 0.13, getting 82.53 degrees, all right? Now, where is cos positive? First quadrant, so x is equal to 82.53 degrees plus K360, or x is equal to 360 minus, cos is positive in the fourth quadrant, so 360 minus the answer, 277.47. Right. So I hope you guys understood everything there. Remember, there are more difficult questions. I will share this paper with you, right? So this file, you can have a look at it. There's still Mpumalanga and Limpopo province left. You can work with those questions there. Limpopo, let me see. Anything difficult? Okay, we did something similar here. Right, so not difficult at all. Okay, so I think we've covered everything. Right, so I hope you guys understood everything, right? And